Okay, so for this problem they want us to factor completely, but it's not clear. Usually when we're factoring, we're just dealing with whole numbers, with integers. Because, let's say for example, I have v squared minus 3, no common factors. Well, let me factor out a 3. Right? That's kind of dumb. Right? 3 times 1/3 is 1. 3 times 1 is 3. But you can always factor out some fraction. I could factor out 7 if I draw it correctly here. Right? 7 times 1/7 v squared minus 3/7, because 7 cancels with 7, giving us 1. 7/7 is 1 times 3 is 3. Right? Nothing about this expression would tell me to factor out a 7. But if I'm allowed to have rational coefficients, I could do so. So what do they want us to do here? Well, definitely not factor out a 7. But if we were to try to add these, we would get a common denominator. So let's see. This is 9 times 3. This is 9 times 9. Let's get 81 as a common denominator. So v to the 6th over 81 minus 32v cubed over 27 plus 256 over 9. And so to get that common denominator, I'm going to multiply by 3 over 3 and by 9 over 9. All right, v to the 6th minus 3 times 32, that's 96. 256 times 9. Goodness. I'm not sure that this is what they want us to do. Let's back up a little bit here. 81, I said is 9 times 9, right? Well, v to the 6th is also perfect square. 6 is 3 times 2. So this term here is v to the 3rd over 9 squared, right? V to the 3rd times v to the 3rd, 3 plus 3 is 6. 9 times 9, 9 squared, is 81. So here I have something squared. Let's leave this middle term aside for a minute and just look at this last term. Here I have a 9. And 256, that sounds familiar. 256, I think that's something squared. I think it's 16 squared. Let's double check. 16 times 16. 6 times 6 is 36. 6, 7, 8, 9. 1 times 6 is 6. 1 times 1 is 1. 9, 10, 11, 12, 13, 14, 15. 256. So this is 16 squared. Not 16 ninths squared. I don't have 81 here. It's just 16 squared. And here I also have a 9 times 3 over 32. That's 2 times 16 times v to the 3rd. Does this fit the perfect square trinomial? Let's see. All right, so this is, if I write it as a 3 here, that would be something squared. So let me replace my 9 with a 3 squared. So that's 16 squared over 3 squared. That's 16 thirds squared. We already recognize this as v cubed over 9 squared. And this is minus, so I'm alleging it's that. Let's switch colors here. shift this down a bit. And let's actually multiply this out. So v cubed over 9 minus 16 over 3. Right? I'm just writing it again so I can actually use FOIL here. So v cubed over 9 times v cubed over 9. That's v to the 6th over 9 times 9, 81. Check. V cubed over 9 times 16 thirds. 9 times 3 is 27. But it's not plus, it's negative 16, so that's negative. And negative 16 thirds times v cubed over 9. So 16 v to the third over 9 times 3, 27. And then 16 thirds times 16 thirds, both negative. 16 is 256. 2 negatives, that's giving us positive. 3 times 3 is 9. Now these two terms have the same denominator, and they're both v to the third. They're like terms in terms of denominator, and they're like terms in terms of the variable. So negative 16 plus negative 16 is negative 32, and that is where we started. So the process of addressing a problem that you're not expecting, that you may be not familiar with, takes sometimes going down some dead ends. But I recognized perfect square. This is a perfect square. Something fishy about this is making me think, yes, it's a perfect square. So it's this red thing times the green thing. In other words, the red thing with the little 2 here. So let me type that in. V cubed over 9 then make sure you hit the right arrow to get out of the denominator, minus 16 thirds, right arrow, close parentheses, and then put the square at the end. Well, what did I do wrong here? V cubed over 9 minus 16 thirds squared. Okay, let me think about this. V cubed over 9 minus 16 thirds squared. 1 over, oh, I know. They don't want me to write it like this. Well, I don't know, but let me suspect. They want me to write it as 1/9 as a coefficient times v to the third. Notice how this wasn't v to the 6th over 81. It was the coefficient 1/81th times my variable. So they want me to write it as a coefficient times that variable. Oh no, there's some other error. All right, let's double check this. I thought this worked out here. Let me take some time off camera. All right, now this is annoying to me. I tried one more time writing it out as, instead of using the squared, writing it as the factor twice. But they're saying I should have factored out 1/9 as a common factor for the whole thing. Now, if I'm already going to have a fractional coefficient, I don't see how this is really better than this, right? If anything, I should have factored out what I was starting with, factoring out 1/81st, and then everything else will have whole numbers in here. But I guess that's what they wanted. You could have factored out 1/3. I guess that's it. They wanted you to factor out 1/3 as a common factor from these two, and factor out 1/3 as a common factor of these two. And that gives you 1/9 times 1/3 v cubed minus 16. All right, I don't think I assigned that problem because this is a dumb problem. Hopefully the exercise of me thinking through it was still useful for you. No, I'm not going to do another one like that. All right, here, this is interesting. I don't have any numbers, but I do have a d as a common factor. So that d can come out just like if it were any other number. Now this is a sum of perfect squares, not factorable. So I just factor out the d. C squared plus y squared. And again, for problems like this, be extra careful that you have the right variables in the right spots. C and y and d. Okay. Fantastic. All right, here we have even more going on. So that's a 3 and a 6. Those have a common factor. Let's just write this out. B squared, that's b times b. P squared, that's p times p. 6, that's 2 times 3, times b times p. I hope I'm enunciating clearly enough. You can hear all those differences. When it's not so obvious what the common factor is and what's left, I'll often write the prime factorization out here, because then I can just circle, maybe, I can circle the 3 that they have in common, a b that they have in common, a p that they have in common, and that's all they have in common. So 3bp, not to be confused with British Petroleum, 3bp times this, and 3bp times this. So there's my answer. We have a 3bp in common, and alphabetical order is preferred. bp up front, minus 2. There we go. Next question, 2 pi. Okay, so here's one that comes from real life. 2 pi hd plus 2 pi h squared. That's the surface area of a cylinder. But you don't need to know that. 2 pi hd has 4 factors, 2 and pi and h and d. 2 pi h squared has 4 factors, 2 and pi and h and h. They have 2 pi h in common, so then this is just a d, and this is just an h. Right? It might look intimidating, but pi is just a value like any other number. Now they gave us the pi symbol here, so we want to use that. D plus h. Okay, now here's another one where we're factoring out a binomial, right? Factor completely, x plus f, that's a common factor. Whatever the values of x and f are, there's some in this part of the problem is going to give you the same value as there's some in this part of the problem. X plus f equals x plus f. So x plus f is a common factor. Here I have x plus f times this thing. Here I have x plus f times this thing. Right? If this was x plus f times a plus x plus f times b, factor out that x plus f, you're left with a plus b. A plus, why did that go twice? Plus b. Right? Now, what's interesting about this a and b is when I'm adding, these grouping symbols don't matter, right? This is really just 4 terms, and 2 of these terms are the same. Y plus y is 2y. Here's some like terms. Negative 2 plus 7. Negative 2 plus 7 is 5, right? 7 minus 2, that's 5. So I put my parentheses around my x plus f. I should have done that right away. X plus f times 2y plus 5. X plus f, 2y plus 5. Oops. 2y plus 5. Fantastic. All right, same idea here. R plus 3 is my common factor. So I factor out R plus 3. Then what's left, I have R minus 3, and then minus P. Now this time I don't have any common like terms. I don't have any like terms here, so I just leave it like that. Easy. All right, here, that's a little ugly. So let's write that down. V squared, let's go back to a less bold color than the red. V squared, that's V times V, plus 5 times V, plus V times F, plus 5 times F. So I've got a bunch of V's in the first three. I've got 2 5s here, I've got 2 F's here. I'm thinking factoring by grouping is going to be useful. Let's look at the greatest common factor of just these two. That's a V. Greatest common factor of these two is an F. F times V, F times 5. There you go, V plus 5 and V plus 5. So there's my common factor, V plus 5. That gives me the V. That gives me the F. V plus 5, V plus F. All right, and let's leave it there. We'll get to this one in the next video.